Hello, my name is Braden Stump, and I'm here today from Handix Scientific to talk to you about our water condensation growth tube technology that we specifically license and manufacture for people to use for bioaerosol collection. The technology has been used in the veterinary space, the human challenge space, as well as ambient bioaerosol collecting and everything in between. And so we're excited to talk to you about the cool and new applications of this technology. The main thing to think about when you're thinking about Handix Scientific's bioaerosol collection technology is that it is a gateway between bioaerosol of interest that you're looking at and means of analyzing it and looking at it in a way that you are actually hitting your limit of detection. So if you have viruses, bacteria, exhaled breath, fungi, proteins in the air that you're looking to capture, our technique is really well specialized at efficient capture across a wide size range of particles in the air, and specifically bioaerosols that you're looking to capture. The bioaerosol is then sampled into a collection media that is retains viability upon capture, depending on the technique that you use, or at least can keep its genomic information intact for techniques where you're looking for presence of bioaerosols as well. We also typically have concentrated and convenient samples that are easier to work with than a lot of other techniques. So we think of ourselves as the world's best middleman between bioaerosol that you're looking to capture and learn about, especially virus, and techniques downstream such as RT-PCR, qPCR, culturing, sequencing, TCID50 assays, and things like that. Our technology itself is a water condensation growth tube collector, which we license from the company Aerosol Dynamics Inc. The technology is based off of effectively works the same way that breathing in air into your lungs on a cold day works, where particles such as bioaerosols are pulled at a constant rate into a tube. And based off of having a wet wick on the walls and temperature changes through this tube, as well as airflow through the tube, you end up creating a blanket of water around particles that makes them, one, easier to capture across a wide size range, and two, easier to impact gently into a media where you can retain its viability upon capture. What that means is a specific advantage of capturing a very wide size range of particles while also retaining the ability to effectively have these be captured gently as well. So you'll see from 5 nanometers all the way up to 10 microns, our particle collection efficiency is near 100% or at least greater than 90%. And especially in this virus range, that's where a lot of other competing techniques typically fall off in collection efficiency or need to use more aggressive techniques that can hurt microbes uh, in order to capture them. And if you're utilizing a technology that captures all particles like a filter, extraction techniques can typically negatively affect your limit of detection or be difficult to complete. Additionally, we see a large advantage in our technology with viable collection or genomically preserved collection of bioaerosols. So we've seen tons of publications from customers and collaborators, such as Lindsay Marr's lab at Virginia Tech, or John Lednicky's group at University of Florida, and then C.Y. Wu with University of Miami, capturing viable H5N1, H1N1 influenzas across the board, as well as SARS-CoV-2 Delta variant, OC43 coronaviruses, as well as MS2 bacteriophage at high rates of viability in animal model studies, as well as in human challenge study sampling in the air. This publication was particularly interesting because it came out in 2020, and the New York Times wrote an article about it because it was kind of proving and helping to push towards the smoking gun of aerosol-based transmission of SARS-CoV-2. Since our technique is gentle in collection and utilizes this cool, patented, novel technology, we typically see smaller liquid volumes, more convenient liquid volumes, and being able to sample into buffers such as PBS with bovine albumin, or time-resolved samples, samples for microscopy, or even pre-treated swab samples that can be broken off into commercial off-the-shelf vials. The key here is that we typically see much more convenient sample methods downstream that pair better with customers' final analysis method. Finally, just wanted to bring up, we have over 150 samplers in the field, and we've been in business for over 8 years. We are continuously coming up with new form factors of this technology, but have three main product lines that we feel very confident about. And we've seen lots of publications on our website, and I think that that's an easy next step point if you're interested. So finally, feel free to be in touch. Thank you for your time and looking forward to discussing more. Have a great day.